we're going to look at how to convert from other bases to base 10. Now, given that ABC base x, given this, we just want to establish a theorem. Given that ABC base x, to convert ABC base x to base 10. But let's clarify this. This x here is not in base 10. Okay, this x here is not in base 10. So if you have this problem, you're asked to convert to base 10. This is what we do. So A BC base x, you are going to multiply each of these respective numbers by x. So A by x, you are going to separate each of the terms with an addition sign, plus B by x plus C by x. Having done that, you are going to introduce an exponent beginning from 0, 1, and 2. Now the exponent you've introduced affects these numbers alone. It affects this x here, it affects this, it affects that. So let's see what happens. So we have A times x raised to the power 2, we have x squared, x raised to the power 1 is still x, and x raised to the power 0 is 1. From the idea that any non-zero number raised to the power 0 is 1. So we have a s squared plus bx plus c. And this is the answer to the problem ABC exponent x. Now, so let's support this theorem here with a question. We have 2, 1, 3 base 4. We are going to convert this to base 10. Now let me advise you on this. Anytime the problem is given to you, even the problem itself can tell you the base of which you are dealing with. If it is in base 4, it means all the values here should not be 4 and should not be greater than 4. So if you have a case like this, the question is correct. But assuming the 3 here is 7, the question becomes wrong. If the 3 here is 6, the question becomes wrong. If 1 here is 5, the question is wrong. Even if 2 here is 8, the question is wrong. So all the numbers here, all these 3 numbers should not exceed 4 or should not be equal to 4, but it can be less than 4. And it can't be a negative number too. So take note. So let's move. So per what we saw up here, we are going to multiply each of these respective numbers by the base. So 2 times 4. Separate each of them with an addition sign. 1 times 4 and 3 times 4. So 0, 1, and 2. So 4 raised to the power 2, that's 4 squared is 16. 4 raised to the power 1 is 4. 4 raised to the power 0 is 1. So 2 times 16 making 32. 4, 3. So what do we have? 39 base 10. And that's the final answer. So when you have any number to base 10, that's what happens. Now let's look at this case, a case whereby we have a decimal number 101.11 base 2. We are changing this, or we are converting into base 10. So we go by the same trend. And we have 1 by 2, 0 by 2, 1 by 2 again, 1 by 2, 0 by 2, and 1 by 2. Now this point here, so we don't need to put a point here. We still go by, we separate them with an addition sign. Now we are here. 1 by 2 again. Another 1 by 2. Now, considering the first, that's, let's assume a whole number, the first whole number, or the first part, that's 101. So we begin from 0, 1, and 2. So we have 2 here, we have 1 here, and we have 0 here. After that, the next two numbers is after the point. That's 1 and 2. So because it is after the point, we introduce a negative number. So you go to -1, and the last one -2. So let's move on. So we have 1 times 2 squared is 4. 2 raised to the power 1 is 2. 2 raised to the power 0 is 1. 2 raised to the power -1 is the same as 1 over 2. And 2 raised to the power -2 is the same as 1 over 2 squared. I will clarify this. A number raised to the power any negative number. I'll clarify that. So let's move on. So 1 times 4 is 4. 0 times 2 is 0. 1 times 1 is 1. And we have 1 times 1 over 2 is 1 over 2. 1 times 1 over 2 squared is 1 over 4. So having arrived at this point, so the summation of all these values, so 4 plus 1, 5, making 23 over 4. 23 over 4. So this is the final answer to the problem. This is the final answer to the problem. Or let's say 5.75. Yeah. So that's the final answer to the problem. So when you have a decimal number with a base, that's what happens. If I have a number, let's say a number a exponent -1. This thing you see here means that 1 over a. That's what indices is saying. If you have a case like this, it means 1 over a. However, if I have a, something like this, if I want this thing here to change into a positive sign, I need to reciprocate this. So when I reciprocate it, see every whole number is over 1. So when I reciprocate it, it becomes 1 over a exponent 1, which is the same as 1 over a. So that's what happens. So if I have, let's say, let me write it here. If I have, let's say, x -2, indices is saying that it is x -2 here. The same way, it is x over 1 -2. I want this exponent to change into a positive exponent. So what I do is that I reciprocate this, and this one becomes 2. So the square here affects 1. 1 raised to the power 2 is still 1, and the square here affects x, making x squared. That's why when you have 2 exponent -2, we had 1 over 2 squared. So that's the meaning of it.